I'm going to be talking about collective intelligence. I'm going to be talking about augmented human knowledge. I'm going to be talking about knowledge management, advanced knowledge management. And I'm going to be showing practical example of that today, right now, with a demonstration. Is that okay? All right, so Florian, maybe you want to talk about, give a few words about yourself.
Yes, I'm Florian Picard. I am research engineer at the CEA, which is the French Alternative Energies and Atomic Energy Commission. And the CEA is a key player in research, development, and innovation in many areas, especially for technical research for industry.
Okay. So I asked Florian to join because you will see that it's a good match. How do we do IoT? How do we do Industry 4.0? And how do we mix that with human in a way that is very practical? Okay. So this slide that I'm going to show now gives a summary of what we do, what PICC solution does. It is a very good summary because we tackle 3 main domains. First, capturing human know-how. You all know how it is difficult to capture knowledge. You have to go to reports, write templates, etc. Imagine you could capture this know-how by talking, taking a picture, as easily as that, recording, and the software, using AI, will do the work of finding solutions for you. Imagine if you could augment this know-how that you've captured in a K-map that you see there, graphical representation of knowledge. You can augment it with knowledge existing in documents, patterns. So go and search for what you don't know, and this is being done automatically. You talk, you see what your colleagues know, and you also see what others know, your competitor know, your patents know, automatically. Imagine if on this network you could focus on a given point and connect this point to sensors to measure pressure, to measure transactions, so that when the pressure reaches a certain degree, automatically you are being warned and informed. We are augmenting human knowledge, making human make better decisions and faster. The last part there, we've loaded everything that has been invented since the last 400 years has been modelized. More than 4 million inventions modelized, all loaded. So PICC is also capable to say, okay, well, this problem that you're having, 20% of people worldwide, regardless of the industry, who had a similar problems, these are the top 3 ideas that help them solve the solution, the problem. So, in a nutshell, I would say the problem we are solving is the lack of actionable knowledge. Knowledge that helps humans make a decision. The lack of actionable knowledge made available to all employees, any place, any time, in any language. You speak German, you load your knowledge in German. Florian speaks French, he's going to see your knowledge in French. This is a problem we are tackling. So, by actionable knowledge, what we mean is that when you have a question, you have a problem, PICC will show you automatically existing solution to this problem. And if you have a solution, PICC will show you automatically known risk related to this solution. Can you imagine how much time you would save if you could do it on your smartphone, on your coffee break, at home, you think of something, and you get access to all the knowledge of your company has been gathering since many years, documented or non-documented. So I'm going to show you a demo. I'm going to show you a quick demo. And of course, this is a demo environment. Okay. You can talk, you can record. I won't do it here because you can take a picture. But imagine I say, okay, I have a problem with dust contamination. As soon as I hit enter, you see the first innovation. PICC is going to access various sources inside your company. It could be your SharePoint, your document management system, reports, everything that he is allowed to analyze. He's not just going to index those and look for keywords. That's easy. But being able to read those documents and understand when a sentence is a problem and when a sentence is a solution, that's where the innovation is. 15 years of research and R&D to achieve this with different laboratories. So therefore, you type a problem, PICC shows you in red, you type a word or a sentence, in red, known problems, and in green, known solutions. Next step, I click on the solution, and automatically PICC will zoom in on this solution. And PICC will tell me, well, Constant, this solution was helped to solve this problem, but be careful, if you apply this solution, this problem may occur in the future. And by the way, inside your company, Patrick Martin is a key opinion leader. It means that he's the one who has been confronted most with similar problems. So the more you use PICC, the more PICC AI gets to know you. It knows the type of problem you had, the type of solution you propose, and it's able to recommend you to your colleagues when other people have similar experiences. Of course, you can present this in different form, like a wiki or different format, you can represent that. So you also see a picture of the solution here. Now this picture was automatically cut inside a PDF. It read the PDF, it saw the picture, it cut it, and showing it to you. So, as I said, PICC will automatically understand who are the key opinion leaders. Patrick Martin, 29 problems related to this topic. He proposed 4 solutions. James Marley, 11 problems, 6 solutions, and etc. How to capture knowledge is a big challenge for all companies. Well, it's as simple as if you have it on your smartphone and you see that you're not satisfied, you have a big red button here, you click on it, I want to capture this as a knowledge. It's a solution or problem. I can record my voice, take a picture, and assign it to the project I'm working on or the department I'm working on. It is as simple as that to capture knowledge when you're facing the situation right away. You don't wait. You're here, you have a problem, picture, talk, capture, assign it to your department or to your project so that you don't forget. No emails, nothing. First thing. So another thing is, how do we load data into PICC? So one way is real-time, talk, record, PICC text to, and etc. There are 2 other ways of capturing knowledge. You have here what we call projects. You can have different projects that you're working on. And you also have here corpuses. Corpuses are a set of documents. You can have thousands. For COVID-19, we loaded like 20,000 documents inside PICC. Now, loading document in a system, that's easy. You all know how to do that. All the document management system know how to do this. But if I take, for example, here we've loaded patents. I'll start with best practice here. This is best practice PowerPoint document. And I select it. Ability to, no, I'm not, this is a test. I want to take something that is more realistic. Okay, like this one. Ability to read a document and automatically extract from this PowerPoint the solution it's talking about, the problem it's talking about, the key opinion leaders, that is different. Indexing is simple. You can type keywords. We also can do that. And it will find you which document talks about this keyword. But finding problems, solutions, and the relationship, that is innovative. And something else, if I look at a patent, for example, I'm going to look at, you can load thousands of patents. For example, this is a patent. It reads the patent, extract from the patents problems and solutions and the relationship between those automatically. And in addition to that, it also automatically tags the patent. So if I come here, it would tell me, well, this patent talks about temperature, weight, carbonate, and etc. The bigger is the bubble, the more problems and solutions the bubble has. The more the bubble is on the right, the more the bubble has solutions. The more the bubble is on the top, the more it has problems. So if you select 100 documents, patents or reports and etc. inside your company, it will help you identify which topics are the more problematic, where each topic have more solutions in order to know where to focus for those of you who do continuous improvement. You can do this for documents. You can also do it for projects. Now, you have different types of documents, structured, unstructured. I'm not going to go into all the details, but I want to show you that you also have projects. And inside project, for example, take this project, you will have a K-map. Now, the K-map is a graphical representation of all the knowledge we've gathered on this project, linked. Now, the good thing here is that, okay, you have different types of problems. You have here the machine instability. The machine equipment does not carry out the instruction given by the control system under all conditions, blah, blah, blah. You have different kinds of problems. For each problem, you can attach videos, you can attach, okay. For each bubble that you see there, you can attach a sensor. This is human knowledge, you agree? This is cognitive knowledge. Now, if you see a triangle, it means that this problem is the core problem, is the most influential problem, is the problem that will impact the most out of the knowledge that you have. If you are able to put a sensor on this problem, it means that on real time, you capture pressure, for example. So when the pressure reaches a certain degree, this problem is going to generate a new problem, and an email is going to be sent to somebody. We are mixing human knowledge with IoT in order to help humans make better decisions, anticipate, and be proactive. Florian is going to show you this in more details. They have a real example on this. Last but not least, of course, this is a graphical representation. You can represent this knowledge in a table view where you're going to have the list of problems. You can have FMEA, manage risk, sort them according to risk. You can represent them in a Kanban view in order to do to move a problem from one phase to another. The advantage of this is really you can automatically identify core problem and influence between problems and solutions. So far, so good, guys. This, I know that this is a different way for you guys to manage and to see how knowledge can be managed. We are moving away from traditional way of managing knowledge, where you have documents, you search, you have to enter templates, where it's becoming more active, more real time in any language. I would like now Florian to take over. Yes, I'm going to go back to the presentation because he's going to show you a real case of how this was applied in Industry 4.0. Florian?
Yes, thank you. So at present, the industry is really in progress, determined by constant digitalization and the management of the information which comes now from everywhere. So that is why we are talking about smart optimized factories, which will be managed efficiently and in real time in order to guarantee greater flexibility and performance. The use of sensors through the Internet of Things, IoT, helps the devices and instruments of the plant to improve the knowledge of what is happening at all times and everywhere, and as a consequence, to be able to correct errors and improve. So an optimized smart factory allows operation to be carried out with the least amount of improvisation and the greatest reliability. Thanks to these advances and dedicated applications, employees and control systems can anticipate and act before problems occur, rather than simply reacting to them after they just occur. So this feature can include the identification of anomalies, breakdowns, identification and predictive resolution of quality problems, monitorings of safety problems, and of course, maintenance. So also according to this type of manufacturing, the collected data will be more transparent. Visualizations of real-time data can change the way products and processes are handled in factories. So next slide, please, Constant. At CEA, we decided to increase the value of our hardware solutions with a K-map, as you can see here, based on our partners' expertise. In fact, it's not only an embedded intelligence, it's above all an embedded expertise. So the first value of this kind of K-map is problems identification, which with connections and interactions between themselves. So at the beginning of a project, K-map is also an efficient tool to identify the right sensors at the right place in order to identify and characterize problems still based on our partner expertise. The IoT, the Industrial Internet of Things, is necessarily a customized approach. We never propose standardized solutions because we have to propose a breakthrough description with a huge advantage regarding competitors of our partners. The second value of K-map is the identification of solutions based on our partner experience, still the same. At the end, we use K-map as a real-time problem solver, which is connected directly to what we call now the Internet of Tools. That is to say, we see sensors and artificial intelligence all together in order to help decision-making for the best performance and biggest impact. Thanks to the use of this kind of K-map, from the beginning to the end of the project, transfer to operational environment is accelerated. So next slide, please, Constant. Alors, as you can see here on this graph on the right, using raw data is not useful for a maintenance operator. This is just noise. It is perhaps interesting for the scientists. They want to understand and improve, but not to take a decision in the factory in real time. So we are here in the case of the maintenance of machining protection systems. As you can see on the left side, you have the milling cutter and the piece being produced with a lot of metal chips, shavings, dust, oil, and all of this kind of stuff which have not to be in touch with the machine motorization and power supplies in the back side, in the other side of the machine. You cannot see here, behind the protection. So this is why we need protection gloves to separate these two sides of the machinery. So we implemented accelerometers directly in the backside of the protection in order to identify motion problems, inclination modifications regarding the nominal configuration of the protection part during the milling process. These data are interesting to detect, for example, a drift or something which is going wrong in real time. Moreover, what is the most valuable for maintenance operations is firstly to link these measure parameters with typical well-known behaviors, shavings accumulation between two folds, holes, and ribs, those kind of things. And secondly, it is very useful to get an alert signal since they are not 20 hours a day close to the machine. So if you have a signal before an event, you can save time and money. To do this, we perform data fusion and we use artificial intelligence, such as machine learning algorithm. The result of the analysis is shown on the dashboard Grafana with a gauge. Voilà. Thank you, Constant. Located here in the top right window of the screen. So we define a threshold of confidence in data interpretation before considering a validated phenomenon. So this phenomenon has been identified as a problem with PICC software. For example, here on the top left windows, an orange disk entitled bourrage copeaux in French, sorry. The K-map knowledge mapping links this problem to a solution of cleaning the protection. So it is the disk is green. The disk green entitled nettoyage automatique is for the time green. Due to confidentiality, we use this basic item to illustrate. So in the first second, the machine is a nominal progress, and now you can see here the gauge is beginning red. We simulate shaving accumulation between two folds with a piece of foam. You can see here just below the yes, here. In order to introduce a local degradation of the motion of the protection. So when the integrated sensors measurements lead to a wrong behavior according to the artificial intelligence, the percentage of proven error will increase progressively. Here, 64%. So at this moment, the gauge shows an increase of percentage leading to a red status. Simultaneously, in the top left windows, we will see that the orange problem disk is turning to a brighter color. And at the same time, in the mailbox of the maintenance operator, here, yes, thank you, on the right bottom, an alert is received by the maintenance operator. On the contrary, when we remove the foam, simulating the shavings accumulation corresponding to the solution proposed by the KMAP, so we clean the shavings accumulation, the percentage of the gouge is progressively decreasing, becoming green. It's coming, yes. And then the orange problem disk is polar, and an email is received by the operator, which confirms that the proposed solution has been performed and the problem solved. Yes, like this. So you can see here the connection between the PICC, sensors, the maintenance operators, in order to solve an identified problem. So to conclude, PICC helps to identify and monitor the decision making. We provided a measurement system that is based on the phenomenon features depicted by the partner itself, and correctly structured and digitized in the KMAP thanks to the PICC solution. That's the added value of the PICC softwares in terms of decision efficiency with greater reliability. It is a customized and well-adapted approach. Indeed, it is not the IoT provider who is the expert of the process, but the maintenance team itself. So thanks to the PICC solution, we determine also the right sensors to identify the problem correctly based on the experience of our partner. In fact, it is good to know in real time what is happening, but it is better to know what to do in real time. Thus, and as a consequence, Smart Factory helps decision-making based on historical data collected by PICC solution and in real time to its connection with IoT devices, including sensors and also artificial intelligence. So,
thank you, Florian.
Okay.
So this sentence here is really the heart of PICC. It's good to know. It's good to know in real time what's happening, but it's better to know in real time what to do. This is actionable knowledge. Knowing in real time what should I do right here, right now, in this circumstance. What's the best decision to take? So we decided to show this example to show the link between IoT, smart manufacturing, human knowledge, collective intelligence, know-how. Of course, we have cases where PICC is being used in bank and insurance for RegTech. You have a lot of documents there, a lot of regulations, how to make sure that the employee is always aware of what to do at the right time and in his language. So the other thing I want to also highlight is that if he can move to the next slide. Well, I'm going to force him. It's that it's all human-centric. It's all about human. It's not about machine. It's not about IoT. It's not about human, artificial intelligence. We are using machine learning to serve human. That's why we like to say augmented human intelligence. Not to replace human intelligence, but to really augment it. It's impossible for anybody to have constantly a K-map in his head all the time. And if all the elements of the K-map are connected to sensors, it's impossible to follow. That's what we are trying to do, and making this available on a smartphone. In addition to that, we also help employees by generating procedures, business processes that the employees can follow. I'm going to show you quickly this example as well. A really simple example. We have, I've created a shortcut here. For example, here we have, for certain employees that are on the shop floor, when they have to do a visual characterization of a problem, they would execute. I thought I turned my, they would execute the procedure like this on their smartphone. They would either scan a QR code, and automatically there will be a procedure that would appear for what they scan, the different step. The procedure would tell them first you have to make sure that you wear all your security items. Then maybe a video is going to be shown to him to explain to him what to do. And the next step, PICC is going to teach him what is good versus what is bad. You can even go on a Google map and say, okay, PICC would tell him where he has to go for the next control, the next check, and etc. So step by step, PICC is going to guide the user on how to think given a certain circumstances. I'm going to show you another example of this that a multinational is using for all its plants, 60 plants worldwide. When an end user is facing a problem on the shop floor, they call it root cause analysis. First, it's going to ask the user, for which plant do you work for? I work for this plant. Okay, which machine are you working on? I work on this machine. For this plant, this machine, these are the different molds. Which one are you having a problem with? This one. These are the different products that are made on this plant, this mold, and this machine. Which product are you having an issue with? This one. And automatically, PICC is going to say, well, in the past 6 days, in the past 20 months, or the past 12 months, these are the top 10 problems that people have faced on this machine, mold, plant, and product. Are you having any one of those problems? Yes, I'm having this one. And then PICC is going to show a picture. And step by step, actually, PICC is going to guide the end user to the best solution, validated by the company. Or it's going to train the end user on what to do concerning a given issue. And if the user doesn't find any solution, he can always add a new problem, a new solution, take a picture, record a voice to explain what the problem is having, and people will see it immediately. Of course, you have statistics on that. You can have statistics for a given business process, for which problems, which molds, statistic of what happened for this, what are the top plants that had issues with this process, molding machine, and etc. I won't go into those details. So the point I'm trying to make here is that, if I come back to the presentation, is that PICC really helps people not only to train, but imagine you got a new employee, a newcomer. He's having a problem on a given process, on a given step. He sees the process, and then PICC will show him a video, show him the problems that other people had, and also show him the key opinion leader who he can contact for this particular element of his process, and this in real time. This is why we say it's also human-centric. So if I summarize, this slide is a bit technical, I agree. We turn information that you find in your knowledge base into actionable knowledge by showing solution, risk, and processes related to what you have. So we can capture human knowledge, business process, link with SAP or the ERP, and also sensor, in order to help, again, human beings to make better, faster decisions. Application is multiple application. I mean, you have, for innovation management, Forestia filed many patents. Those of you who know Chanel, Gabrielle, perfume, latest perfume, mascara 3D, in the patent you will find the name of one of our partners. They use PICC for that. Samsung, they filed patent. Using ArcelorMittal, they have filed patent. So a lot of our customers are filing patents using PICC, of course, for human capital, build know-how, build perform Industry 4.0, social responsibility. You can have open innovation projects with schools, universities to collaborate on projects. And of course, for academia, PICC is being used by more than 22 universities to teach innovation. So that's it for me. And I hope that during this presentation, you've learned something, because we have like 22 labs at universities, and CEA is also a lab working all year long to do research on how to make knowledge more easy, more transmittable, more integratable for the companies. Okay?